and notice that the output does not show the text written. Wrap the open function in a with block. This code now uses the built-in file context manager. A problem occurred and the cursor never gets reset, and a context manager needs an exit method. In this video you will see two examples. First, I show a context manager that is built in Python, and then I show how to create and use one yourself. Here are variables a and b. I will divide a by b and write the result to a file. I execute the code. I open the result file, and that works. Notice the text written in the terminal. But now I change b to 0 and run the program again. The program crashes, and notice that the output does not show the text written. That means that the file was also not closed. We have no idea in what state the file is at this point. You could wrap the problematic code in a try except block, but you would still be responsible for closing the file. Wouldn't it be great if there was some construct that guarantees closing a file once you are done with it? And of course, there is. Let me show you. Instead of returning the file from open, I wrap the open function in a with block. The result of open is assigned to file with the s keyword. I indent the next lines, and there is no need to manually close the file anymore. This code now uses the built-in file context manager. I execute the code again. Now the code still crashed, but this time Python automatically closed the file that was opened. The context manager does not relieve you from checking your inputs, but it guarantees to clean up things that were opened when the exception occurred. Before I show you how to create a context manager yourself, there is one more thing you need to know about them. A context manager ensures cleaning up things after your code, even if bad things happen. You also know how to use one with the with keyword. But a context manager can also set up stuff for you. Let me show you one of my favorite things to do with context managers. Here is the code to create a window with a button. Let me check if that works. That works. I close the app and add a button click handler. When I click the button, the waiting cursor should appear. I connect the function and execute the code again. I click the button and look at the cursor. That works. I divide again and reset the cursor. That works. The code is so fast you of course don't even see the waiting cursor. But you already know what I am going to do. A problem occurred and the cursor never gets reset. Now I know that you have seen this millions of times in apps you use every day. You wonder, why does the cursor look so funny? And there is a great solution for this problem. Let me show you. I create a context manager called waiting cursor. The context manager gets a window when it is instantiated. But what makes a class like this a context manager? Well, the first method it needs to implement is $enter. This will execute things before the code in the with block is executed. In this case, set the cursor to waiting. Then a context manager needs an exit method. The exit method has 3 parameters with exit state. I'll print them. And then set the cursor to default. You already saw how to use a context manager. Notice that I am not assigning the instance to a variable because in this example I don't need to interact with it. I indent the division code. I set 0 to 5 again. That works. Look at the exit parameters. The context manager exits normally and all values are none. Now I divide by 0 and test the program again. An exception occurred, but look at the cursor. And look at the output. The exit method was executed even if an exception occurred in my code. It is of course the Python data model with its special methods that turned a class into a context manager. And if you want to learn more about this, enroll in my Udemy course Python Objects with Special Methods. There you will find the most used special methods in Python. A link is in the description. And that's all for this video. Thanks for watching.